Julia. I'm from Brazil and I'm currently a student of PPCR 2020 Principles and Practice of Clinical Research. And finally guys, I made it. Let's do a review of Module 2 Basics of Statistics, and the bibliography I'm using is our course book, Critical Thinking in Clinical Research. Look guys, I'm a student, I'm not a TA, okay? So critical thinking while watching these videos. Okay guys, so finally talking about this data distribution. So what is it? So data distribution is how data is distributed. So how data is spread out, how we characterize the data. It can be normal distributed or it can be skewed or non-normal distributed data, okay? So first, what is a normal distribution? Well, so a normal distribution can assume or can take a bell-shaped curve, or also known as Gaussian curve, I don't know. And what is the main point here of a normal distribution? Mode, median, and mean have the same value in this normal distribution, right? So here I have the most frequent value of my data set. At the same time, this is also my mean. And this same value represents the fifth percentile of my data set. So it is the median of my data set. Okay? Well, so a normal distribution is unimodal, so I have only one mode, and a symmetric distribution, so the curve is symmetric. The tail is both tails have the same size and length. Okay. Well, so what is the other option rather than normal? Skewed or non-normal distributed data, and I can represent this data like that. So here I have the left tail of my data set longer than the right one. So I can say that here my data is left-sided skewed. Okay, so I have a left side skewed distribution of my data. Okay, and what is this pink line here? So here this pink line represents my fifth percentile. So I have as a pink here my median of the data set. Okay, so median. What is the blue line here? The mean. And what is this black dot here, black point? The mode of my data set. So here in my skew data, I would have what would be the central tendency measure that better represent the data set? The median. You can see that mean is more skewed than the median, right? So I can use median as a measure of central tendency in this particular case. And here, the right tail, same thing. It's longer than the left one. So I have a median more centralized than the mean, than the mode. So again, I should use median as a measure of central tendency in right-sided skewed data. Okay? Okay. But how can I access this normal or non-normal distribution? And how can I say how skewed is my data? How much does data deviate from a normal distribution? Well, we have three ways to access data distribution. What are they? Graphical representation, so I can use histograms and box plot that I've already mentioned. So the advantage is that they tend to be pretty obvious, so when you just take a look, you know the data is not normal. However, it is subjective. You cannot trust simply looking at a graph, and you cannot be sure that the data is or not normal distribution. Okay. Then we have numerical assessment. Well, so we have here two ways of measuring the normality or the distribution of the data. So first is skewness. As the name already says, skewness measures how skewed is the data. So if skewness is 0, so obviously I have a data that is not skewed. So I have a normal data distribution, okay? If I have a value of skewness that is less than 0, then I have my data set being skewed to the left side. So I have a longer tail. My longer tail is the left tail. Okay. If I have a positive value as skewness, then I have a right-sided skewed data. Okay. Okay, guys. Then we have, besides skewness, we have kurtosis. What is kurtosis? Well, it assesses the thickness and width of the curve. So thickness and width of the data set. Okay, of the representation actually of the data set. Well, so if I have values around 3, then I have a normal distribution. If I have lower values, then I have too few outliers. What is too few outliers? So theoretically, a normal distribution would be something like that, right? If I have too few outliers, then I don't have these outliers, right? So I don't have these. That means I have, as a curve, I have a rectangle. Okay, so I have a rectangle here. That is not a curve. So in practically speaking, we cannot have lower values than 2. Okay. Then if I have higher values, then it means I have too many outliers, so I have longer tails. But I cannot infer which side is longer. If my data is like right-sided skewed or left-sided, for example. Yeah, right or left. Yes. So I cannot say so. Then I would have to apply skewness to find out that. Okay. Then I have, as a third option of accessing data distribution, I have statistical test, and the most famous one is Shapiro-Wilk test, and it compares the mean and the median of this data set I am evaluating with a normal data set that have the same mean and median. So if this comparison as a result gives me a z-score higher than 0.05, then I have a normal distribution. If this comparison, if my data is not equivalent to this data the test took as basis, as an example, if I have a lower score than 0.05, a z-score, then I have a non-normal distributed data. Then I'll have something more or less like this. Okay?